In this video we're going to look at the volume and the surface area of both cones and frustums. Let's start off with the cone. This is a right cone. We say it's a right cone as we have a right angle between the height h and the radius r. So this is a cone with a radius of r and a height of h. We can say the volume is given to be 1/3 pi r squared height. This is simply 1/3 of the cylinder. In an exam, this formula will be given. We're going to start the video by finding the volume of cones. We're then going to go on to finding the volume of frustums. We will after that do the surface area of cones and the surface area of frustums. So let's look at answering some questions. We're asked to find the volume of the following containers. So the first one is a cone of base radius 5 centimeters and height 12 centimeters. So what I'm going to do is just model this up. So here is a cone and we have now a right angle just here. So let's put the right angle on, and we have a perpendicular height of 12 and we have a radius of 5. So I can say that the volume is going to be equal to 1/3 multiplied by pi multiplied by the radius squared. 5 squared is going to be 25, and then we're going to multiply this by the height, which is going to give me 12. If I do this now, I can do it either on a calculator or non-calculator. 25 times by 12 is 300, divided by 3 is going to give me 100. So we could say that the volume is going to be 100 pi, and that would be centimeters cubed. We're looking at a volume. This is what we call an exact answer, or an answer in terms of pi. From our previous work, we've seen that pi is 3.14159 and so on and so forth. So if we wanted, let's just put this in here, we could write this as 100 pi, and that's going to give us 314.159 and so on and so forth. So I could say that this is going to be 314 centimeters cubed, and that's given to 3 significant figures. So let's look at another one here. This one here, we've got 7 and 5. So in this particular case, we would simply square the 7, that would give us 49. We'd multiply it by the 5 and plug it in here. Okay, let's look at some other ones. These ones are nice and straightforward. This time we have a cone of base radius 9 and a slant height of 15. So we've got a bit more work to do here, and what I'm going to do is model this up. So this time we're given the slant height. The slant height isn't the perpendicular height. So if I just look at this now, we've got our right angle just here, and we're given now that the slant height on here is going to be 15. So this is 15, this one is going to be 9. What we're looking for is the perpendicular height. We can use Pythagoras Rule or Pythagoras theorem to find this height here. So we can say that the height is going to be the square root of 15 squared minus 9 squared. So let's go ahead and do that. This is going to be my height. My height is going to be the square root of the hypotenuse of this right angle triangle, which is 15 squared minus now 9 squared. And we can write that this is going to be the square root now of 225, that's 15 squared, minus now the 9 squared, which is going to give us 81. And we can see from this that this is going to give now the square root of 144. The square root of 144 is going to be 12, and that gives us the height. So we can now use the formula that the volume is going to be 1/3. We'll have pi, then we'll have r squared, which is going to be 9 squared, that's 81, multiplied by the height, which is going to give us 12. If you were unsure here, you can simply use the calculator. So this is the square root of 15 squared minus 9 squared. That's going to give us now our 12. We multiply this now by the 81. We can divide our answer now by 3 and multiply by pi. That's a bit of a long way round, but as you can see, we're going to get the answer. So that would be 1017.8 and so on and so forth. So we could write this now to three significant figures. The volume is going to be 1020, and we're going to be working now again in centimetres cubed. All volumes are given in cube units, so whether it's centimetres or metres. If you wanted here, you could cancel the 12 and the 1/3. So if we do that, we can say that this is simply going to be 4 times by pi, and then we're going to multiply that by 81. So depending on how confident you are with your work with fractions, you can go ahead and do that, and that gives us this value right here. Okay, let's look at this one. A cone with a base diameter of 20 and a slant height of 25. So again, we've got the slant height instead of the perpendicular height. We've got a diameter this time. If the diameter is 20, we can say that the radius is going to be 10. We know that this is a right cone, so we can put on here that this is 25. So we can say that the height, we've got the height now on here. Height is going to be the square root of 25 squared minus 10 squared. That's 625 minus now the 100. And again, we can work that out if we want on here. So square root now 25 squared minus the 10 squared. That's going to give me on here 5 root 21. So if we wanted that as a decimal answer, 22.9. So what I can say now is that volume, so the volume is going to be 1/3 pi, then we're going to have now the radius squared, which will be 10 squared, which is going to give me 100, multiplied now by what we call this exact value, and that is the height, and the height is going to be 5 root 21. So 5 lots of the root of 21. Keeping it like this makes sure that it's accurate. So I could write this in the calculator as 1/3. So 1/3 times by pi, so we can write it as times by pi, times by 100 multiplied by, if I like, I can overwrite 5 root 21 in, or I can just use the answer that I had. So that gives us 2399.43 and so on and so forth. So we could write this now, let's put this in as 2400. So 2400, and again, centimetres cubed. That gives us the volume of a cone. It's 1/3 pi r squared height. With these ones, nice and straightforward as we're given the correct value for the formula. That formula here, the 1/3 pi r squared height, will be given in an exam. Okay, we're told a cone has a volume of 183 centimetres cubed. Whilst to calculate the value of its height, h, if r is equal to 5 centimetres and pi is equal to 3.142. We're asked to give our answer correct to the nearest millimetre. So just be careful here, because we're working in centimetres, they want the answer in millimetres. So let's model up what we have. We have a cone. We're given now the value of the radius, which is going to be 5. We want to find this height just here, h. So this is the perpendicular height, and we're told the volume is 183. So the volume is 1/3 pi r squared height. So we can write that 183 is equal to 1/3 multiplied by pi, which is going to be 3.142, multiplied now by the radius squared, 5 squared is 25, multiplied now by the height. So what we're looking to do is find the height. So all I simply need to do is divide both sides by this quantity, 1/3 multiplied by pi multiplied by the radius squared. So I can say 183 divided by 1/3 of 3.142 multiplied by 25 will give me the perpendicular height. If they were really nasty and asked for a slant height, we could find this out using Pythagoras from this answer here. Okay, let's go ahead and do that. So in the calculator, we've got 183. We're going to divide this by 1/3, and I can put them in brackets if I like, or multiply. 3.142 0.142, and we're going to multiply that by 5 squared, which is 25. That gives me 6.989, so let's write this in, 6.989 ... Remember, this is in centimetres, so let's just check that. So 6.989 and so on and so forth, and they want the answer to the nearest millimetre. So we could say that that is going to be 70 millimetres. So given our answer to the nearest millimetre, we can say that h will be equal to 70 millimetres, or if you like, 7 centimetres. So with that one, we're working backwards. Okay, if we look at this one, it says a wine glass is in the shape of a cone on a stem. The cylindrical tumbler is used to fill the glass of wine. We're asked to find the diameter of the tumbler so that it has the same volume as the wine glass. So let's look at the volume of a cone. This is just a cone. The volume of the cone is given now as 1/3 pi r squared height. So if we look at this, we have a radius of 3. We need to be careful here, we're given the diameter, so we can say this is going to be 1/3 pi r squared. Well, the radius is 3, radius squared is 9, and we're going to multiply this by the height, which is 10. So if I look at that, I can say as an exact value, this is going to be 90 over 3, which is going to give me 30 pi, and that will be centimetres cubed. That's the volume now of this wine glass. If we look at this cylinder, what we're going to have here now is the radius, and I'll put this on. So if we go ahead and do that, we can put the radius on. The volume of a cylinder is simply pi r squared multiplied by height. It's the area of the cross section multiplied by the height. So we've got now pi, then we've got r squared height. So we can say now the following. The volume, which is going to be the same as this one, is going to be pi. We're going to have r squared multiplied by the height, which is 12. So what I'm going to do is set these equal. This is the volume of this one, this is the volume of this one, and now they're going to be the same. So just putting the units on here, we've got centimetres cubed. And I'm going to use the sign, therefore, if these are equal, 30 pi will be equal to now, and I'll write this as 12 pi, and then we're going to have r squared. We can divide both sides of this equation by pi, so if we do that, and we can divide both sides of this now by 6 to make our life slightly easier. We could say that this is going to be 5. Let's write that in white to make it easier. We can say now, dividing both sides by 5 pi, that we're going to have 6. Just looking at this now, we can divide, so that's going to be 5 is equal to 6. So divided by 2, that's going to give me that. Poor explanation, I've just divided both sides from here by 6 pi. And then we can say now that 5 over 2 is going to be equal to r squared. We need to take the square root of both sides. Technically, we can have a plus or minus the square root of 5 over 2. It will be the positive as it's a length. So if we do that, we can take the square root now of 5 over 2, or if you like, 2.5. And that's going to give us now the root of 10 over 2, so let's put that there, the root of 10 over 2, so root of 10 over 2 is equal to the radius, therefore the diameter is going to be now twice this, which is going to give me the root of 10, and we can find the root of 10 is going to be about 3.2, 3.1, something along those lines. So root of 10, let's put that in, 3.16. So the diameter is going to be 3.16, and that will be centimetres. Remember, it's a length, that's what we're doing. So we're asked to find now the diameter such that it has the same volume. We've just set them equal and solved an equation. So do be careful. As I say, my explanation here wasn't brilliant, but hopefully that makes sense. Okay, let's move on. This now is a frustum. What we've got is a large cone, and we've cut it into a smaller cone and the base. The base is called a frustum. What we can do is work out the volume of a frustum, and we do that by finding the volume of the total cone, and then we subtract away the smaller cone. So what I'm going to do is put some dimensions on these, and we're going to look at a formula. So I'm going to have a radius here and a radius here. These are going to be different sizes. What I'm then going to have is the total height of the cone, which is going to be like so. And obviously if these were put together, we wouldn't have this gap. And then I'm going to have now the height of the smaller cone. So let's just put this on. What I'm going to say now is the following. This length right here is going to be r, that's the radius, and this is going to be h. This is going to be capital R, and this is going to be h. So if we want the volume of the frustum is going to be 1/3 pi. We're going to have r squared, that is the large one. So r squared multiplied by height minus 1/3 pi, then we're going to have the smaller one, which is r squared multiplied by height. If you want, you could factorise this and write this as 1/3 pi. We're going to have now the large r squared h minus the small r squared h. All I've got here, and I think if I just put it to one side, let's just put that on here. This now is large h, and this is the large R, or if you like, capital H and capital R. So that's all we would do to find the volume. We find the volume of the total cone, and then we take off the top, and that gives us what we call a frustum. So if you think a lampshade might look like this, a plant pot, anything along those lines. So let's have a go at some of these ones. What we're going to do is work out the volume of some frustums. So here is a frustum. We've not got the top here, so what I'll do is just put these on. With some of these, let's just extend that line right there. That's what we're going to have, and it'll look something like that. I mean, that's not brilliant, but hopefully you can get some idea of what this would have looked like. In fact, let's just make it a bit more realistic. That looks a bit better. We can, on some of these problems, use similar triangles. These, remember, are going to be similar triangles. We can see now, if I just extend this up, this is not a great sketch here. What we've got is the following, and if we look at that, this is a similar triangle to this one just here. Okay, so we can see that that from there is going to give us something looking like that. Okay, so let's go ahead and work this out. So we're going to put on now, and we'll do this, let's take that away. So if we look now at the volume of the larger cone, that has a radius of 8 and a height of 9. So what we'll have then is the large one, so we'll put on here the large cone. So this is the large cone. So the volume is going to be 1/3. We're going to have pi, then we'll have the radius squared, which is going to be 8. 8 squared is 64, multiplied now by the height. The total height is going to be 9. What we're going to do is now subtract the smaller cone, the top of it, and that will leave us the frustum. So the volume of the smaller one will be 1/3 pi, then we're going to have r squared, and the r squared is going to be 4 squared, which is 16, multiplied now by the height. So if we do that, the height is going to be 3. We can tidy this up, and that's going to give me now 100, let's just do some quick maths, 192 pi, and that will be meters cubed. All I've done is divided the 9 by the 3 and multiplied up. This one right here is going to give me now 1/3 of 3 is 1, so this is going to give me 16 pi meters cubed. I need to subtract the smaller cone from the larger cone, and that will give me the frustum. So just putting it here, frustum, what we're going to have is the 192 pi meters cubed minus the 16 pi meters cubed, which is going to give me 176 pi meters cubed. I like to work in exact values. We can find a decimal answer by simply plugging that in. So 176, our pi button is just here, and that's going to give us now 552.9, and I'll say that that's 553. So 553 meters cubed, correct to 3 significant figures. So that's a nice straightforward example. It would of course be easier if we had the top bit to see, but we're simply working out the total and then subtracting it away. Okay, let's have a look at another one. A bucket is made by cutting a cone into 2 parts as shown in the diagram. If the rim of the bucket measured 30 centimeters diameter, calculate the amount of water it will hold, correct to the nearest litre. Okay, let's look at what we've got here. We need to be nice and careful with this, and I'm going to actually draw it up to the side here. What we've got is the following, and this again is a right cone, a right angle cone. We've got this, and I'm just going to cut it off just here. So let's look at that. We can see that the total height is going to be 80. So this one here is going to be 40. This one here is going to be 40. If we just consider that this diameter just here now, the rim of the bucket, this part here, measures 30 centimeters. So what we can say then is that the radius will be 15. If we now consider this right here, this is split into 2, so using similar triangles, this will be split into 2. Remember, these are proportional. So what I'm going to do is find now the volume of the larger cone, and that's going to give me 1/3 pi. Then we're going to have r squared. R squared, 15 squared is 225 multiplied by 80. That gives me the total volume. From that, I'm going to subtract now the volume of the smaller part. So if I just call this now V1, V1 is the total volume, minus V2, which is this small one. And that's going to be 1/3. Then we're going to have pi. The radius squared, 7.5 squared, is going to give me 56.25. You can do that one on a calculator if you like. Multiplied now by the height. The height is going to be 40, and we can work that out. Again, you could work with the similarity of these if you wanted, and that is covered in another topic, but we can do this anyway. So again, you might want to factor this. You might want to just do 1/3 pi, these two multiplied, minus these two multiplied. So if you really wanted to tidy it up, the volume of the frustum, we could write this as 1/3 pi, and then we could do now 225 times by 80, and we could subtract away from that the smaller one, which is 56.25 multiplied by 40. Depending on how you are in terms of the confidence. Work out this one, subtract them away. All I've done is factored it here. So I can write this as pi divided by 3, or 1/3 pi. Then we're going to have now 225, so 225 times by 80. From this, we're going to subtract now 56.25 multiplied by 40. And that will give me the volume of the frustum, or the bucket. So we got 5250 pi. Let's put this on. So 5250 pi. That is what we call, and remember this is centimeters cubed. This is an exact value. It's in terms of pi. So if I wanted to do that now, we've got this number here. So 16,493.36, and so on and so forth. I'm going to leave it though just now as an exact value. If you're asked to give it now to 3 significant figures, 16,500. So let's write this here. So 16,500, and that's going to be centimeters cubed, and we've got 3 SF. So that's what we've done on that one. So nice and logical, and it works out quite nicely on that one. So that's that one done. Okay. What we've got here now is a little problem. We've got a frustum, but we don't have the top bit. So let's see what we would have. And all I'm going to do is model this up now as a right angle triangle. So if I model this up, what we've got is now, and this one's quite nasty because again, the units are different. So using similar triangles, what I'm going to have is the following. I've got 10 centimetres down here, so let's put that on. So this is going to be 10. This part is going to be 3. This part is going to be 4. Now you can work off similarity if you like, or you can simply say that this is now going to be the length x. So from here to here. What I'm looking for now is the height here. So if you're comfortable with doing similarity, you can do. So all I'm going to do from here is the following. Just going to write now using similar triangles that x over 4. So we can say now that x over 4, so x over 4 is going to be equal to x plus 3 over 10. Again, if you wanted to use the similarity, you're more than welcome to try it that particular way. I'm just going to now multiply both sides of the equation by 10, so we'll have 10x, and multiply both sides of the equation by 4, we'll have 4 lots of x plus 3. So 10x will be equal to 4x plus 12. Subtracting 4x from both sides, 6x will be equal to 12, and x will be equal to 2. So we can see now that that length is going to be 2. So what I've now got, and I'll just quickly sketch these up, we've got, and let's grab a triangle instead, make this slightly easier. We've got 2 different triangles. So let's put these on. What I'm going to have now is the larger one, and the larger one is going to be a 5, and this is not accurate, a 5 by 10. This one is going to be now a 4, and we've got this height right here of 2. So that's what we've got, and we can work on it from here. So if we look now at the volume of a larger cone, and we'll call this now, we'll say that this is going to be V1, this is going to be V2. We can say that V1 is going to be 1/3 pi, then we're going to have r squared, which is going to be 100, multiplied by the height, which is going to be a total of 5. If we then subtract away from that V2, which is the ever smaller one, 1/3, then we're going to have pi, we're going to have the radius squared, which is 16, multiplied by 2. So if I do this, I can write this now, and I can write that the volume of now, we'll call this V3, we just want this pictures here, that's what we're looking for. I'll call this one V3. So V3 is going to be V1 minus V2, so let's write this here. V3 is going to be, we can write this as 1/3 pi. This is going to give me 500 over 3, so 500 over 3, 5 times 100 divided by 3, minus now 32, so 32 over 3. So I'm remaining now accurate with these fractions, and we can tidy up from there. What's that give us? 468, 468 over 9. I'll just get a value for it now, and we'll do this one as an answer to 3 significant figures. So we're going to have pi divided by 3. We're going to have now 500 minus the 32 divided by 3. And that is going to give me now on here 52 pi, which is 163. So we can say 163, and the units we've got here are going to be now, remember this is centimetres. I converted the millimetres in centimetres, centimetres cubed. And that again looks, I think I did that to 3 significant figures. So that is going to give us now the volume of the frustum. Okay, let's move on. We're now going to look at the surface area, the curved surface area, and the total surface area of a cone. If we're given the radius and the slant height L, we can say that the curved surface area without the base is going to be pi RL, or pi LR. We simply multiply the pi by the radius multiplied by the slant height. This is just the curved surface area. If we wanted with the bottom, the area with the bottom is going to be pi RL plus the area of a circle, pi r squared. So if we go to the fair or the seaside and we get chips in a cone, it wouldn't now have a top, but if we put a top on it, we would need to add the area of a circle. Okay, so let's have a go at this now. What we want to do is find the surface area without the base and with the base of some of these. A cone with a base radius of 9 and a slant height of 15. So if we do that, what I'll do is grab one of these up, we'll put it just here. So this should be relatively straightforward. We've got a slant height of 15, so that's 15 centimetres. We've got a base radius of 9. So without, this is just the curved surface area, we need pi RL or pi LR, which is given in the exam. So we can say now that the area is going to be equal to pi multiplied by the radius, which is 9, multiplied by the slant height, which is going to be 15. So if we wanted to do that, the area is going to be 135 pi, and we could work that out to 3 significant figures. So 135 multiplied by pi, and that gives me now on here 424. So if we look at that, the area is going to be 424. We're working with centimetres. It's an area, so it's centimetres squared. If I wanted to find this surface area with now the circle, I would have to go ahead and add. So with now the bottom plus pi r squared. So we're going to have now adding to this pi multiplied by the radius squared, which will give me 81, and we can find that value. So if I do that, I'm just going to add to it now 81 times by pi, and that will give us now the surface area with now. So we've got 216 pi, which is 678.5. So we can say 679. So 679 centimetres squared, correct to 3 significant figures, with now the lid as well. So nice and logical, nice and straightforward. Okay, let's try a different one. A cone of base radius 5 centimetres and a height of 12. So if I get this one back up, this time we're not given the slant height. We are though given a radius and we're given the height. So if I put this on, we've got now the radius is 5, the perpendicular height is 12. Using Pythagoras, this squared, so 12 squared plus 5 squared, will be equal to now the slant height squared. That's one of our special ones. That's going to give us 13. If you're unsure, you could say that L was equal to the square root of 12 squared plus 5 squared, which is going to give us the square root of 144 plus 25. That gives us the square root of 169. The square root of 169 is 13. So all I need to do from here is simply write now that without, so this is now the surface area without, we use that the area is pi RL or pi LR. So the area is going to be pi multiplied by 5 multiplied now by the slant height of 13. So what's that give us? 65 pi, and we can get a decimal answer there. So if we do that, we'll have 65 pi. So if we get to 65 pi, that gives us now 204.2. So we can say 204, and that is going to be centimetres squared, correct to 3 significant figures. If we wanted it with, we would just simply add now pi r squared. So pi times by the radius squared. The radius is 5, so I could add that to my answer. Plus now 25 lots of pi. So if we do that, we're going to end up now with 90 pi, or 282.74. So 283, and we'll just write this down. This will be 283. That will be centimetres squared, and again, correct to 3 significant figures. So that's finding the area, the surface area of a cone with or without the circle. Do check if you're given the base or not. Okay, let's go back. Let's go back and look at this particular example. With this one, we might be asked to find now the surface area of this frustum. So let's have a go at that. If we think we've got now a circle at the top, a circle at the bottom, and we've also got a curved surface area. Let's think about what we had here. This was our larger triangle of the cone, and this was the smaller one. So what I'm going to do is break it up. I'm going to say that I need now a circle at the top. So let's do that. And we'll assume now that this is a closed frustum. We'll say that it's got a top and a bottom. If it was a light shade, it might not have either, but we'll assume that it has both. So what I'm going to have is now the top, and we've got a smaller circle. We're going to have the bottom, and then we're going to have now a curved surface. So if we work out the top one, this one is going to be pi r squared. So that's a circle there. So pi r squared is going to give me 4 squared multiplied by pi. This one right here is going to be 10 squared. So working in centimetres, this will be 100 pi. So that's got me the top and the bottom. What I'm now going to look at doing is finding the curved surface area here. So I'm going to take now the curved surface area of the whole of our cone and subtract away the smaller bit. So this one right here, we need this length right here. This is L for now the overall cone. So this is going to be the square root, using Pythagoras, of 10 squared plus 5 squared. 10 squared is 100, 5 squared is 25, so that length is the square root of 125. This length right here is going to be the square root of 4 squared plus 2 squared, so this is going to be the square root of 20. So what I'm going to have is this particular curved surface area. So I can say now that the curved surface area, and I'm going to say that that will be A, is going to be the larger one, which is pi, multiplied now by the radius of 10, multiplied by the root of 125, and then I'm going to subtract from that pi multiplied by the radius of a smaller one, which is 4, multiplied by the root of 20. So in a calculator, what I'm going to have is the following. I'm going to have 116 pi plus now pi, and we're going to have on here 10 lots of the root of 125 minus 4 lots of the root of 20. Quite a lot of work to do, and you could simplify and factor that if you wished. So let's go ahead and find now the total surface area of that closed frustum. So 116 pi, then we're going to add to that now pi multiplied by 10 lots of the square root of 125. I have done this fairly rapidly. Hopefully you're hanging in there, understanding how it's done, and it should make logical sense from here. And that's going to give us the value. So 659, and I'll say that this is going to be 659. That will be centimetres squared, and that is given to 3 significant figures. So that is the total surface area. Okay, so that's what we've got. 10 centimetres, 4 centimetres. I've used the information we had before, and we found the surface area. So a recap then, we've looked at the volume and the surface area of cones, and the volume and the surface area of frustums.